Okay, so this is section 1.4. So this is the last part of our first chapter on chemistry stuff. There's chapter 2 of chemistry unit. That was what I planned on trying to finish this week. I know that's not going to happen, but I would like to start chapter 2 tomorrow, probably, and then finish it up like the first of next week. So thinking about having like a test on this stuff, or a quiz per se. All your quizzes and tests I'll be putting on the Google Classroom. So they're open book tests. Okay? So you do whatever you need to. I don't care if you look stuff up, because all I want to know is that you can do the questions, okay? So that'll probably be like at the end of next week. Alright? So that's when you guys won't be here, so then you'll have to go on to online to do that. Alright? Anyway, we'll go through all of this before then. Or I might make your test when you guys come back the following week, just so that I can see, or like answer any questions in person before you do it. But I'll let you know. Anyway, so this is talking about quantifying acid deposition. So all the stuff on chapter 1 is about acids, and how we monitor its effects. So this is talking about how it affects the environment. Yesterday we talked all about how it affects the environment as well. And if you didn't see that, there should be the link to it on the classroom under 1.3. You should be able to watch the video. Let me know if you have any trouble with that. Anyway, so it says significant data can be collected in 2 ways. So how do we collect data on acid deposition? What is acid deposition? Calvin should know because we talked about it yesterday. Minerals in the soil? Minerals in the soil are the buffers.
Acid that's deposited in the soil.
Perfect, yeah. Acid that's deposited in the soil. And how is it deposited? Well, probably mostly due to acid rain. So that's how we would have acid deposition. I'm gonna write that right here, acid rain. So it rains down and then it soaks into the soil, and then your soil becomes acidic. So there's 2 ways we can collect data on data in general: qualitative and quantitative. Do you know what those words mean? You've heard those words before, I think. Quantitative as a quantity. What's a quantity? A what? Yeah, an amount, a number. So think of qualitative data as having numbers. So if I wanted to test the soil, I'd be like, the soil has a pH of 5. That's a quantitative data point because it's got a number. How can I qualitatively tell you that the soil is acidic? What is So qualitative has to do with qualities. So I can explain qualities about it. Without numbers. So quantitative, I tell you the pH of the soil is 5. Qualitatively, I could be like, the soil must be acidic because this type of plant grows in it. Or this soil must be acidic because there's no life in it. There's things not living here. So you're just making like observations and being able to write those down. They're qualities about the soil. Does that make sense? So in your life, you always explain things either qualitatively and quantitatively. Me, I'm a science math person. I always like quantitative data, like numbers. They make sense to me. Someone who's more of a English social person, they like to explain things. They like to use words to explain things. That would be more qualitative for you. When you're reading a book in English and you're like, they explain things really well, like they're trying to set the scene and they explain all these details about something. That's qualitative data, it's details. It's the qualities or the details about the scenario. So as scientists, we always take in both of these. We always write down qualitative and quantitative. Especially as like a biologist or environmental scientist, being out on the land, you're not going to be just test some water. Like I can test the water, yeah, I get a pH of this, but we need to write down some other things. So we want to write down the temperature. Okay, that's a quantitative data too. But we might write like what it looks like outside. So like, oh, it's a cloudy day. That's a qualitative piece of information. Right? It's rainy. It looks sort of rainy. Not rainy, but like cloudy, like it might rain. I don't think it's supposed to rain now. Anyway, so it says use page 203, question 41 to categorize examples of data as either qualitative or quantitative. I guess I will have to open that up. Okay, just give me a second on the desktop. So it says to go to page 203. This should be, or it will be on your Google Classroom. So you can open up the textbook onto page 203. I'm going to zoom it in. So what they want us to do is they want to look at this data in this question, number 41, and they want us to put it into the table. So they're just giving you scenarios, and they want us to say whether it's qualitative or quantitative. So I want to do this with you just to figure it all out together. Okay, so the first one, it says spots present on the surface of a leaf. So is that a quantitative or a qualitative piece of data? Spots on a leaf. Yes. So qualitative data, spots on a leaf. Can I go back to that? Perfect. Population sizes of organisms within an ecosystem. So the population size, is that qualitative or quantitative? Yeah. Population size, because it's got a number, right? Well, it should. Unless you're just saying, yeah, the population's really big. Then, but you're still referring to a number, so that really is a quantity. Information from hunters and inhabitants within the area. What is it? The question was information from inhabitants of an area, so people that live in an area, just information that they give you. Yeah. But I forget what the exact word was. Information from hunters and inhabitants. I'm just going to say info from hunters. I'm really summarizing this. Number of plants demonstrating chlorosis. What's the key word in that sentence? Number. Yeah. So number of plants of whatever, doesn't matter. They're just trying to throw you off with all these words. It's a number. That would be a quantitative information. Soil pH. I told you that one before. That's my example. Yeah. So soil pH is a number. So that would be a quantitative piece of information. No. This is not letting me go across. Give me a second. Concentration of aluminum ions in soil and water. Concentration, is that a qualitative or quantitative? You said two different things. Concentration. You said the right answer the first time. A concentration would be a number, right? We calculate that, so it should be a quantitative. You said quantitative at first and then changed your answer. Don't second guess yourself, you're right. Concentration. So whenever we're dealing with that concentration, any sort of number, we would use that quantitative. Population of young fish. We've already had population of something else. That's going to be quantitative. Population of fish would be quantitative. Observations of fish health. So again, the big keyword there's observations. That would make it a qualitative. A list of insect populations within the area. That's a tricky one, maybe. Because whenever you think population, you think quantitative, but it's a list of the different types. So technically, that would be qualitative. So a list of populations in an area, you're saying like, oh, there's jackfish and there's rainbow trout and there's whatever. Like you're just saying a bunch of different species. That's not really a number per se. It's not a qualitative piece of data, so that would be a qualitative. The last one I think is list of plant species within an area. So again, list is our keyword there. That would be qualitative. So you think you understand those two words now? Hopefully, with that little exercise. Yeah, that's that. Are you still writing it down, Kevin?
Yeah.
I'm not doing that to you. I'm just next day?
Hold on.
Okay. Sorry.
Yeah, I think all day yesterday.
Yeah. I normally start getting a headache around like 2 o'clock in the day, like every single day. I don't know if it's I use too much brain power and then like finally like don't use it as much anymore. It's like, oh, my head hurts. You could do a 9 a.m.? Oh, at night, okay. And that's a good time to go to sleep. Get ready to go to sleep.
I have headaches when I get angry. I was pretty angry this morning. I was like that. I don't know, my siblings,
Siblings get me in trouble, can't they?
especially after
Especially Andrew.
and
Okay, let's continue on here, because this is recording so people can hear our conversation.
they know a little bit more about it.
There you go. Titrations. So, just like jumps right into titrations. But titrations is something that I would like to do with you. It's probably what we're going to do tomorrow, do a lab of titrations, because it's a fun activity, I think, using acids and bases. So I'll explain what that exactly is. It says titration is a technique used to determine the concentration of an unknown solution by using the concentration of another solution of known concentration. So if we know a concentration of one thing, we can use that to figure out the concentration of another thing. And I used to use this exact technique when I used to do water sampling. So in university, I used to do water sampling. I would go out, I think I've told you this before, go out and every Sunday I would test the water of this river. And it was working for like a non-profit organization that was trying to protect the watershed. So it was like an environmental organization. And I worked with them and I did water sampling. So I would get my water sample, then I would go back home and I would use a titration to figure out the concentration of things in the water I sampled. So the concentration of oxygen, the concentration of acids, all this stuff to figure it out. So this is like a real life thing. I'm trying to link it to, like I'm not just teaching this dumb thing that you're gonna learn in school and never again. If you ever do stuff like that, like soil and water sampling, it's definitely something that is used every day. And sometimes I think about if I change careers someday, I'd work in like a lab, because I would like doing that. You know, just doing like testing and stuff. There's lots of jobs in lab testing right now for COVID, right? They're backlogged so far, so these companies, they're spending all of their energy just testing samples. Like, I think that'd be a fun job. Personally, you don't have to talk to as many people. I'm like a big introvert, so, but I picked being a teacher. So I talk all day. So and maybe that's why it takes so much energy out of me and I can start getting a headache. Like, I talk too much. Anyway, so how we use titrations, it uses both quantitative and qualitative data. How much of a known concentration is needed to neutralize the unknown substance is what we're doing. So we take a known substance and we try and neutralize the unknown. And how we figure out when it's neutralized is with the color change. So we use an indicator. Do you guys remember when we tested acids and bases in the past? You know, like those little strips that you use. We can also take a little sample of your thing and then use like a dropper so you see the color change. That's what we use in a titration. Is it okay that I moved on? You didn't have to write anything there? Or just the underlines? You got this covered? Yeah. So in order to properly do a titration, you must understand all the materials needed and the steps involved. So the materials you need are a burette. You need a burette clamp. We're not going to do this right now, we're probably going to do it tomorrow. But I'm going to just show you what it looks like. I want you to learn the calculations before you have to do it tomorrow. How do I not remember burettes? I think they're in that. So this would be a burette clamp. This thing, it clamps it.
Yeah, just send it out.
And this is a burette. Never been used in the package. So I have a perfect one for using this. So we take this thing and we put it in this clamp. Well, this is not a big clamp. Yes, I can. Either way. So this goes into the clamp, and then there's a little sort of spout on here, and we put like an acid in this normally, and then we write down how much acid we have in it, like by the lines. So there's different lines here. So we'd say it shows you how many milliliters, basically. You can look at it if you like. And then we just have our other solution underneath, and we start that. We open it up, and it slowly goes into your mixture, and you just mix it underneath. And when the color changes, you stop this thing. Okay? It's a pretty easy thing to do. Not a hard task, but it does take, I guess, some practice to do it right, because some people, they'll, like, once you see that color change, you need to stop it immediately. Or once you see like a little bit of a color change, you make it go like less. Because if you open this fully, it'll feel like pouring out fast. It'll feel like going down. So it's just like a matter of making sure that you stop it on time. So attach this, blah, 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 carefully was the burette with distilled water, wash, I think is the word. Close, this is called a stopcock, so that's what that thing is, stop and start. Then fill it 1/3 with water, tilt the burette around, it's just telling you how to clean it. Attach it to the clamp, all this stuff. We're going to go over this tomorrow. It's not too important that I go through all of these steps right now, because when we go through this, when we actually do it, we'll go through those steps. Okay? So all of this, we're using it to be able to do this calculation. And I think you've done this type of calculation before, but not for a titration. Do you remember doing this calculation in Science 20? Or did I skip it for some reason? I don't think I did. This was in Science 20's work that I've already done with them so far this year. So they've already used this calculation. So this is figuring out molar concentration. And sometimes this is the formula that they give you. Sometimes I always use big M is equal to moles over liters. You may have remembered that one. But basically, this big M is your concentration, and then it's equal to your moles divided by your liters. Okay? So that's what that formula means. And then we use this formula at the bottom to calculate our missing amount. So if we have a concentration of our acid, a volume of our acid, it's equal to the concentration of our base times the volume of our base. Okay? So we use that formula to be able to calculate our missing concentration when we're dealing with a neutralization with a titration. Something to remember, and it says that at the bottom here, if your volume's in milliliters, make sure you always change it to liters. You guys possibly remember that? Remember, it always has to be in liters. the formula is moles over liters, not moles over milliliters. So really make sure that you have that always in liters. Okay? So let's do an example. I know that's a lot to take in, and let's try to see if we can do an example with these formulas. I'm just going to write these on the board on the side just so you see acid. Alright, so this one says, what volume of 0.300 big M moles per liter, or concentration, will be required to react with 24 milliliters of 0.250 moles per liter KOH? So they're giving us a concentration, and a volume. So the formula we're going to use is this C acid, V acid is equal to C base, V base, right? We're going to use that one. We're going to solve for the missing one. So let's figure out which ones are acids and bases. So it says 0.300 molar HNO3. HNO3, is that an acid or a base? Acid. How do we know it's an acid? Because it has an H. So whenever it's an acid, it always has that H at the first. So that piece of information is our C acid. Okay? Next piece of information is it'll react with 24 milliliters of KOH. Milliliters, is that a concentration or a volume? No? Volume? Milliliters? Right? That's just the liters on its own. This would be a volume, and that's a volume of our base. Why? Because KOH is our base. And that base is at a 0.200 concentration, so we would write C base for that one. Alright? So we've got our C acid, V base, and C base. The piece we're missing is our V acid. So let's write out the formula. C acid, V acid is equal to C base, V base. Okay? Good so far? Now we just got to plug in the information into the formula. So our C acid we have as 0.300. So right here, I'm going to write 0.300. Okay? That's multiplied by our V acid. And our V acid is the thing we're missing. So I'm just going to write V acid there. Okay? That's equal to our C base. And our C base is 0.250. Okay? Multiplied by our V base, which we found out to be 24 milliliters. What did it say on the other side about milliliters? Converted to what? Liters. We always have to convert our milliliters into liters. So how do we do that? What's 24 milliliters in liters? Do you remember how to do that? No? So one thing you can do is divide by 1,000. Or another thing is to do is to move the decimal 3 places to the left. And I like doing moving decimals. So for me, I would go the decimals at the end, right? Which is 24. 1, 2, 3. So that makes it so that our liter amount is 0.001 0.024. See that? So my extra little red squiggle, that would be putting a 0 there. Okay. Good so far? So now we can put that into our formula. 0.024. And we should be able to solve. This is when you should have a calculator. Oops. If you want to grab one from the Chromebook card, that'd be a good idea. Would you grab one for talking to? Thanks. So what I just did is I multiplied these two numbers together, and I got 0.006. So I just multiplied those two numbers, got 0.006. Now I've got 0.300 V acid is equal to 0.006. What do we do now? What's something we always got to do when we're solving? What always needs to be on one side? You guys know how to do this, you just don't know how to explain it? I know you know how to do it. I've seen you solve for a missing thing. This is our missing thing. We don't know what that is. How do we get rid of it? We need to move our numbers all to one side. So if we have times 0.300 on this side, we gotta divide both sides by 0.300. So to figure out what our V acid is, we would go, these are going to cancel out, so we're left with V acid is equal to whatever this is, 0.006 divided by 0.3. So when I did that, I got an answer of 0.02. And that's a V, so that's a volume, so that's liters. And if we were going to change that into milliliters, because we had milliliters in the front of the question, it was starting out with 24 milliliters. This would correspond to being 20 milliliters. Okay? Just to put it in perspective, if that makes sense. Does that make sense to you guys? Like how to calculate that? Calvin? Is it okay?
Sure.
Don't say sure.
I don't know that.
What happened? You just did a calculation, didn't you? Okay, let's try the next one, and then I will let you try some on your own, just because this Forrest wants to talk to me. Yeah. So I told her, I'm like, can you give me like 10 minutes? And this is probably going to be 10 minutes. So I don't want her to be waiting any longer. She's just taking all the grade 12s. She took Calvin yesterday. So like a good while. That's why I wanted to make sure finish this. Okay, so let's try this question then. We're using the same formula. You guys are going to tell me what to do. You especially, Calvin. So that you're paying attention. Or your brain is right here, focused on this. You're like, what happened? What did you just do? I hope that you don't feel that way after we do this one. So what I'm going to do, just because I didn't do this in the last question, but I should have, and that's my bad, is that I should write on the side what I've got. I just labeled it inside the question. But I should make a little table of the different pieces that we've got in our question. So our question says 30 milliliters of 0.10 moles of NaOH. There's two pieces of information there. What's 30 milliliters? Is that a concentration or a volume? Kelvin. 30 milliliters, a concentration or a volume?
Okay.
It's a base, yeah. It is a base, but is it a concentration or a volume of a base? Perfect. So Kelvin says 30 milliliters is our volume of our base. And he's right. So I'm going to write volume base. 30 mils. The next piece says 0.10 big M of NaOH. Nevis, is that a volume or a concentration? 0.10 big M. Yes. I just put base without an E. Okay. Concentration of our base, yes. Be confident, you got it. So that's our concentration of our base. Good. We've got two pieces of our equation. We just need one more. It neutralized 25 milliliters of hydrochloric acid. 25 milliliters, is that a concentration or a volume? Kelvin? A volume of a base or an acid?
Acid.
Perfect. So they gave us our volume of our acid as being 25 milliliters. Good. So our major problem here, it's not a major problem, our missing piece is what? Which piece are we missing out of our equation? C acid, yep. So we're missing our concentration of our acid. That's our missing piece. Alright? So, before we plug our pieces into our formula, we need to do one thing. What is it? What? Yeah. Milliliters to liters. Is that our P Kelvin? You think we can do that? Yeah. How do we do it?
I actually don't think so.
If you don't know, best way to do it, take this number 30, always divide it by 1,000. You have a calculator in front of you? It'll give you the answer. So take 30 and divide it by 1,000. If that works for you better. What do you get? Fraction? Oh no, not your calculators again. Okay, put your
0.025.
okay, that's this one. And then the 30 milliliter one, if you get a fraction, it should be, just make sure you put a decimal somewhere, like at the very end. You know how you do that in that calculator? Perfect. So on that calculator, if you're doing that in a fraction, you can go 30 and then put a decimal, and then go divide it by 1,000, and then it'll give you a non-fraction answer. I really hate that feature of that calculator.
I press control and then enter.
Yeah, that's also a way to do it. Control enter. Perfect. So now we've got all the pieces we need. Let's plug it into our big formula here. So I'm just going to rewrite the formula down here. V acid, V. Oh, base. I don't even know the formula.
Yeah, you're ringing.
Is what?
Not ringing.
Yeah, it's from the fridge in there. It's really annoying. Sorry. I will close the door in a second. V base and C base. Alright, so now we need to plug that into our formula. So our V acid, if we look at our little chart here, is 25 milliliters. We've changed it to liters. So we're going to plug that in here as 0.025. It's going to be multiplied by our C acid. Our C acid is what we don't know, right? So we're just going to write C acid. It is equal to our V base. Our V base is 0.030 liters. And then our C base is 0.10. Alright, so I've just taken all of the pieces from what we figured out from the question and sub them into our formula. Now what do we do, Kelvin? You don't need to calculate, I just want you to tell me what we do. Sure. Multiply the ones on the right, so you can do that. So 0.03 multiplied by 0.10. What does it give us? 0.003. And then that's all equal to what's on the left. What do we do? Divide. So, Kelvin said we need to divide. What do we divide by? Yeah, so to get rid of it on this side, we gotta divide both sides by 0.025. When we do that, we should get our answer. So by doing that, that gets rid of that. We've got our C acid left, and that's equal to, did we get an answer?
Oh, yeah. 8.33.
No. What'd you get? Yeah, that's what I got. Try it again. 0.003 divided by 0.025. Maybe this is 0 on there.
Or I may have put it wrong. Oh, yeah.
So I got 0.12 or 0.12. So that's concentration. This is a concentration, so we need to put our units in here. It's big M or moles per liters. Okay?
Yeah, I'm smart.
Yeah. I just wanted to make sure you're paying attention. That's all like, Kelvin, what is it? Alright. So I'm just gonna stop here for now. Give you a little bit of time to try some of those out. And then we'll continue this after. Is that okay? So we stopped at, we'll continue after on number 8 of the slides. So that Nevis can go to her